So this is one of the formula from which we can find the value of orbital velocity. And now I'm considering that this satellite is revolving around this planet at a minimum height possible, whatever height at which the minimum height which is required by a satellite to revolve around a planet, so that it can come the gravitational pull of the planet. So what I'm taking is h, which is less than the radius of Earth or radius of that planet. Now consider this thing, h is in few hundred meters, whereas r is 6400 kilometers. So there is no size comparison. That is why if I take this value r plus h, it will become almost equal to r only. So if I put r plus h is almost equal to r, that is why if I am taking this value as this in this equation, I'll get v naught is equal to g times under root g over r, right? No, it was r outside. So it is r times under root g upon r. What does this become? This becomes r is what? Root r into root r. So one r gets cancelled out and left with under root r multiplied by under root g, or I can rewrite this equation as under root r into g, right? So this becomes under root r into g or g into r. Put the values. What are the values? G is 9.8 meter per second square and r is what? 6400 kilometers. 6400 kilometers. This is 9.8 meter per second square and this is 6400 kilometers. Let's convert one thing into another. I am converting this into meters. So it will be into 1000. This value we have to figure out. Or I can write this as 1, 2, 3, 4, 5, 6. 6.4 into 10 raised to power 6. Right? To 10 raised to power 6. And if we sort it out, I'll get this value to be under root 7.92, something near that, 7.92 into 10 raised to power 3 meter per second or 7.92 kilometers per second. So this is the minimum value of orbital velocity for a satellite which is moving in the least possible distance around the Earth. Because why Earth? I'm not saying planet this time, because these values have been taken for the Earth. Alright.